recording. All right, so how much is the space available? All right, so we have enough space available right now. So can you see the screen now and hear me clearly? Great, great. So how are you doing? How are your exercises coming up? Need to understand parameter a little bit more. Which parameter are we talking about, Anand? Okay, so the one which we mention inside the brackets, angle brackets. All right, all right. So, okay, so probably if you go through last 20 minutes of our Java class, I think that would be better. Okay, so basically, does anybody else has that problem other than Anand? Okay, you're getting parameter type issue. Okay, okay. So we can discuss it offline. You can drop me an email. I'll have a look at it and then we'll work it out. All right? I think that would be better. Also, if you are keen on writing the code, a better approach would be to go for GitHub, all right? github.com. So you can create a project with each exercise with your code, and then I can review your code then and there itself. All right? Okay. Other than writing code, the other benefit of GitHub is you get a social presence, which other people, if they like the exercise solution, they might fork it and they might suggest it. So this helps you build your profile as a developer. All right. In today's time, people actually prefer things like GitHub and while hiring people. Okay. So that serves as a certificate for lots of people. Okay, so should we start? Does anybody has any other question before we start? No questions? Great. Sergio, Jim, Johnny, Santana, and Tim. Good. Yes. All right. So yeah, go ahead with your question, Johnny. Okay. So Santana, were you able to run it and did it work? Great, great. Actually, even if you just try to do what I try to do, it will give you a great amount of confidence if you are at a beginner level. And then you can go ahead and improvise and modify a few things and then recompile and run your own code. All right, so now let me Go through some more points. Okay. Is there any setting on the Eclipse tool to turn autofill for commands? So it doesn't force you to do autofill. When you press Control space, only then it autofills. Okay. Press Control space, and then it should do. Rajesh says I tried sysout but did not expand to. You should write sysout and then press Control space, and it should autocomplete. Okay, good, good. And note that don't get confused that where is my output of sysout. It would not come to the console. All right, you'll have to see it through the task tracker, the URL. By the way of URL, you keep on going till the attempt level, and under that logs you will see that there is a separate section of sysout. Okay, there you can see your sysout output. All right. All right, so we talked about many things in the last session. One of that was partitioner. We customize partitioner to tell Hadoop that send these keys to this reducer, send these keys to this reducer. All right. Now, at many points in the discussion, we realized that if the output of each mapper on each machine is combined together before being sent to the reducer, it will be marvelous. It will be great, right? For example, if you remember our frequency computation, a character frequency computation, where we were trying to compute the frequency of alphabets, English alphabets, the only thing I would expect for the data transfer is the the value of the 26 numbers, right? What we trying to do? We were taking a big text. We were trying to do how many times A has come in the text, how many times B occurs in the text, how many times C occurs, and what is the frequency of all these alphabets till Z. Okay, and the our approach was to break it down into convert each word into multiple key values, where key is a single character, value is just one, so that when keys are summed together, the frequency is computed automatically. All right. Yes, Anand, so you were saying something. This link you just send it to me. Yeah, I mean, okay, I did not get your point. Okay, okay, good, great. All right. Now, in those cases, you would want that before we send to the reducer, let's do some processing of these key values in order to get some minimize the network transfer. So, and again, let's go through the a little bit recap. There is input split. We run the mapper, we generate the part, and then okay. I think there is something wrong with this diagram. Never mind. Okay. Actually, this diagram is without the reducer. And this diagram has got mistakes. Never mind. So, what we were saying is before the data is sent to the reducer, we can run on each machines, we can run something called a combiner function. We can create combiner functions which work exactly like your reducer, meaning the data you will get in combiner is key and values, and your combiner has to do something similar to what reducer does, and it will combine that and save it. Okay, it'll just combine it and pass it forward, just like a reducer. All right, now, but since a combiner only runs on a section of the data separately, in case you have one key on one map, another key on another map, you will again have to run the final reducer in order to combine the result, right? So a combiner does not take the place of a reducer. Combiner is a step which is which we want to be executed before data is handed over the network to the reducer. All right. So combiner is called over and over and over and over again on the output of map. All right. So you can imagine that the definition of combiner is exactly the definition of a reducer. When you write a combiner, you don't need to write something separate. You just implement the reducer exactly the same way and tell uh, Hadoop that, hey, this is my combiner, uh, a combiner class. Right now, there are little bit differences. There are little bit differences from the reducer. In the combiner, you are you are not basically given all the values in a single shot. You are called on some values once, and on the result, the combiner is called again. Okay, so if there are so many values for a key, your combiner will be called again and again on those set of values till it reduces to a singular value. Okay, so I'll show you that part. So as part of our okay, so as part of our, let's say there was a mapper, which this is a great class. Okay, so mapper converted it when the mapper got this one. Mapper converted it to T1 H1 and so on. Okay, how should I break it quickly? Okay, how can I break it? Can somebody give me some ideas? Okay, so if I say $1 and new line and $1 slash tab and I say 1, I think it should convert. Yeah, I did. Okay, so all right. So if you see, I just converted into something like a key value pairs. All right. So those who have not gone through regular expression class, they should be impressed that regular expressions can make you do these things really, really quickly. Okay. Now, this is the output of the mapper. Okay, when we were doing the frequency computation of of characters in our input, this is what we get as a mapper, where key is each character, value is 1, just like our word count. Now, after it goes through the after it goes through our uh, after it goes through the Hadoop, it is sorted well, and then these key values are combine together. Okay, like this, it'll become like this. All right, and so on. So this is what your this thing will generate. Hadoop will generate. Okay, now you can see that this has come 4 times and T has come 2 times. All right. Now, instead of sending this data, there'll be maybe in your input, there can be, say, thousands of ones, right? Now, instead of sending all these thousand values, if we combine it on the mapper side itself, it would be just wonderful, right? So, what you do is you let it run through something called combiner, and combiner will convert here itself into, say, 3 here, and this one will get converted into 2, and this one will get converted into 4, and so on, right? One combiner for each mapper. That's how one combiner is instantiated on each machine. Now there is a difference between calling and instantiating. Okay, so combiner, how would combiner look like? Combiner will look like a function called myCombiner, and it basically takes key and the values and it returns some value. Okay, it returns some value, or it basically returns a key value. All right, now this combiner, yes, so you can think of a combiner as a reducer. So we are all clear about this fact, right? The basic definition. Now I want to go ahead with one more step. Now, instead of the way you would have imagined is that for A, your combiner will be called on, my C will be called on 1 comma 1 comma 1, basically A, and an array of 1 comma 1, right? This is what you have imagined, but there is a little bit of a difference. Instead of calling the combiner this way, Hadoop guys realized that it will be far more efficient if we call it in parts, meaning instead of calling on the whole array, they start calling it my combiner on partial data, meaning first this will be called like this. Whatever the result comes in, say, I'm just talking about A, okay? So they found, I mean, Hadoop found that there are two A's in the beginning. So they called my combiner on this. So now this will become something like A and 2, okay? Now they will, again, my combiner will be called on A, and now this time it will be only on the remaining one, okay? Now that will lead to A and 1. After this is done, on the results of previous calls, it will be called again 2 comma 1. Okay, so what exactly is happening is a combiner is being called on partial values, and it's being called recursively. Why is it being done so? Why do we do it this way? So whenever a sorting is happening, how does a sorting happen? Partial data is sorted, and then it is if you remember divide and conquer, the whole array is divided into parts. Each part is sorted, then merged, and then again merged, and it keeps on going, right? So whatever values at every step, whenever it's sorting, it's also combining the values. Okay. If there are a million values for a key, it will call your combiner on something like two values. Okay, it'll call your combiner on two values, and whatever result uh, comes out of your combiner, it will be passed to next sequence of combiners. Okay, is not clear. So now let's imagine. Let me just draw a nice diagram that will make it clear. So if you had an imagine this way, if you had so many values for a, okay, so many values for a, for these two values a combiner will be called, and we will have one value for this. For these two values a combiner will be called and we'll have two values. For these two values the combiner will be called and we'll have one value. And after that, whatever value comes out here, the combiner will be called here. And similarly, once that is done, another combiner will be called here. And finally, we will have only singular value. All right. So, so here, let's say my combiner does average. Okay. What does my combiner do? Let me save this. This is nice. Okay. And let me also say file, new sketch window, and all right. So now you can see that when combiner runs on it, and imagine that our combiner code does summation, right? If our combiner code does summation, it will be 2, and this will be what? 2. This will be what? 2. And this will be what? Yes, quickly. This will be 4. And finally, we will have 6. Perfect. So instead of combining all values together, your combiner will be called on partial section of the data. It will be called on first two values, second two values, and then next two values, and then it will be combined again and again recursively till we get the result. Ideally, in normal reducer, all of this 1, 2, 3, 4, 5, 6, it will be done in a single shot. But in case of combiner, your function, because when it's sorting the data, it is anyway processing two values at a time. So what Hadoop guys did was, while sorting itself, why don't we just start calling combiner? And that's what they did. Okay. So which is organizing this combine. So it is Hadoop's duty to execute your combiner function. Your combiner function, all it does here is A plus B, and there we go. Okay. So your combiner function is very simple. It's returning summation of two values in this example. Now, so Santana, the question, it is clear to you who calls it? All right. Now, Johnny has a good question. Then, what is the use of reducer if it is combined? Now, the way we have a key as A and value as 6 on this particular machine, A might be existing in another mapper, and its number of counts may be 12. Now, you have to sum 12 and 6, right? This total number 6 is only on this machine for a key. Okay. Similarly, similar process might be going on another machine, and you will have to sum it up. And that's when the role of a reducer comes into play. So reducer reduces the value from while multiple mappers, while combiner only takes input from a single mapper. Sounds good, Johnny? Good, good. I'm sure you will be having questions regarding this. Now, a very honest question arises here. If you think through, question arises that are all reducers are all reducers qualified to become combiner, or in another words, if we code anything in combiner, will it make sense? Okay, so let me try to pause everything. All right, so I think let's just kill the Chrome. It might be doing something. Discard it. All right. Now, is it better or do okay? Okay, so let's. All right. So now a very honest question arises that had it been some other function, such as let's say our function of combiner only returns, it says returns average of values. Okay. So does it make sense to have function average as the combiner? Now what will be the average value of this should be how much? Ideally, in case all of this is run, the expected value should be 1 plus 1 plus 1 plus 6 by 6. So average value should be 1, right? Now, now let's see this. Now the average value here is 1, good, 1, good, 1. No, actually this is a bad example. All right, let me take another example. So let's say that we have three values here and we have two here. Okay, and we have three here. Okay, now the average of these values, which is how many? 3, 1, 2 plus 2 is 4, 5, 8, 9, 10. And how much is the average? 10 divided by 7. Right? Now that is the average we are expecting. Now if you see the average of these three values, help me compute quickly. So 4 by 3, okay, and this one is 2, and this one is 1, and if you do a combination of this, it will be 10 by 6, which is 5 by 3, okay, 5 by 3. All right, now when you sum it up with this one, it would become, okay, so 8 by 3 divided by 2 is 4 by 3. Okay. Now, this is not same as what we had expected. We were expecting 10 by 7, right? So, functions like average cannot be recursively called in order to achieve. But uh, functions like sum sum was okay because we just summed it. No matter how many brackets we put, we always get the same answer. It's like putting brackets. Let's compute this first, then compute this first, and then compute this in parallel, and then this. So it's like putting brackets between these numbers in order to enforce the priority, right? Now, question arises that is is mean is min function min function okay for combiner? Johnny says no. Anybody else? This is a very important concept. Okay, this is a very important concept. So there is a name for this kind of functions, and I'm forgetting that particular name. So Johnny said no. Anand is okay. So my question again is is min is min a valid combiner function? All right. Anybody else? All right. Great. So now Johnny is convinced that it is min is a valid function. Now another function, say square root of a into a plus b into b. Okay. Do you think it is a valid combiner? C into C. Basically, ABC is what? Well, if A is basically the zeroth value from the values array. So this may be A, B, C, and that way. So if square root of A square plus B square plus C square and so on up to the last value of values, do you think this function is okay for combiner? Why not? So my question is that let's take four values, okay? Or let's just try to do it here. So when you say 1 is square plus 1 is square plus 2 is square, and then we put a square root on top of it, so it'll be something here, and then there'll be square plus a here, and then a square root. And when we combine both of them, we'll be squaring it, and then summing it up. So if this is A, B, C, D, E, summation will be here. By the time you reach here, it will be square root of A square plus B square plus C square plus D square plus E square. Because here it's square root of A square plus B square plus C square. Here is square root of D square plus E square. Remember, this is square root here. Now, when it is applied again, you will see that the square root goes away. Should I demo you that? What am I trying to say? Okay. Now see this. So here, if this is A, this is B, this is C, and this is D, this is E. So what we are doing is, let's say this is X. Okay, and our y is sqrt d into d plus e into e, right? So this is, if this is x, this is y. All right, and now x is how much? X is this much. Okay, now when you so z will be x into x square root of x into x plus y into y, which is which is equal to square root of a into a plus b into b plus c into c plus d into d and plus e into e. Makes sense? So here finally we will have something of this sort. Okay, our z will be something like this. So effectively, if you see from that same way, you will realize that no matter what, it will we will end up with the summation square root of the summation of all these numbers, square root of summation of squares of these numbers. Sounds good? So the answer is yes. Anand, Tim, Eric, did it make sense to you? Johnny, Jim? All right, great. So it so you're convinced that, so when you are choosing your combiner function, you need to be cautious about this property. Okay? So you cannot choose a combiner. Whenever you're coding your combiner, you need to be fairly cautious about what exactly are you doing. Okay. So if you have to do compute the average of all the numbers, I'll do it little different way. I will basically compute the summation first. Summation and counts, these are the two things I will compute as part of my reducer. And even the combiner, it will be the same function which compute two things, summation and counts. And in the end, we will have two big numbers. One is count, other is summation. And then we can, you know, do the division. All right. The other problem that might arise in big data cases, that when you sum up two things, the resulting number can be very, very huge. Okay. So if you say is the voice clear, because it's giving me warning that voice is not clear. So combiner will have all final output from mapper, from a single mapper. That's correct. Not all. Combiner will have partial output. There will be multiple calls to your combiner functions. Whatever function you have created, there will be multiple calls. In every time, it will be sending a small subset of the total values. Okay, so the final output on a single machine will be passed through the combiner. Okay, so basically, all right. Now the question from Sir Santana is this programmable that do not use combiner for a certain mapper? Yeah, it is. Okay, you mean to say that for certain mapper on the node, don't use combiner? No, that's not something in your control. Okay. You do not say that for this particular mapper in my MapReduce code, say the mapper which is running on first machine, don't run combiner. Okay, that is not something in your control. At most, what you can do in your combiner is for some key ranges, you can not in your logic itself. You can write that if my key is this, don't combine. Let it be the way it is. Okay, that is completely up to your logic. Perfect. Now, Anand's question is how does average flow works in this case? So when we do the average, let's imagine that we have to do an average of things like this. Okay. If let's say we had to compute average, so what our com our the logic in our MapReduce will be to do summation, which is for count 3. Okay. And everywhere we do the same thing, even while spitting out the values from or let's say we put a semicolon or colon. Okay, we put a colon while spitting out from the map, so we just change the definition of our mapper a little bit so that everybody is following thing like summation count, summation colon count, and so on. And here it will be 4 colon 3. In the similar manner, we'll have how much 4 colon 2. We'll not divide it. Okay, we'll not divide it right now. We'll just let it pass. Okay, here it will be 2 colon 2, and finally we'll have summation is how much? 4 plus 4 plus 2, it is 10, and 3 plus 2 plus 2, how much is it? 7, right? And that's how you compute the average. So your combiner and reducer, all they do is they basically compute two values instead of one. Sounds good? Now, when it comes to the big numbers, I'll give you a word of caution. When it comes to big numbers, this number might overflow because of doing the summations. Okay? Although the average might be very small, the total numbers might be tolerable, but the summation of these numbers might overflow, right? And you may question that, hey, the average value, why do we need to compute summation because when we could get away with average, right? Because summation might overflow the total value. In that case, keep the average here, keep the average here, okay? Compute the average, and basically don't compute the summation. You can compute the summation using the other way. All right, so at every point you can basically, instead of retaining the sum, you retain here the average, and whenever you want to compute the average of these two, you basically try to multiply by, you can figure it out. I'm sure you can figure it out. So so if you have average A1 for N1 numbers and A2 for N2 numbers, what will be the average of N1 plus N2 numbers? Anyone? Okay, so first you compute the sum A1 into N1 plus, then you compute the sum of the second one A2 into N2, then you divide by N1 plus N2. Okay, all right. A better technique would be, because here again when you multiply these two values, again there would be a chance of overflowing the limit of long or integer. So what you do is you compute something called n1 by n2. Okay, and you convert this problem into a1 into r plus a2. Basically, you convert this into n1 by n2 like this, and divided by n1 by n2 plus 1. Okay, this way you will not overflow your integer ranges. Okay, sounds good to you? Did I confuse you? So basically what I'm trying to do is I'm trying to avoid the multiplication of two numbers which might overflow things. Like here, the summation of n1 and n2 might cause a disaster. If both numbers are in billions, they might tend to overflow. Similarly, this multiplication might tend to overflow. That's why this r is not going to overflow anyway. It is going to, if these two numbers n1 and n2 are comparable, then you can basically sum up this way. Okay. Yes, A1 is the average of n1 numbers. A2 is the average of n. Yes, yes. Video will be uploaded, Rajesh. You can take a break. And so Rajesh is not well, so he'll be taking a break. Okay, carry on. Yeah, get well soon. Yeah. All right. So Johnny says that I thought A1 is an average of n1 numbers. Yeah, that is what it is, right? A1 is average of n1 numbers. A2 is average of n1 and n2. Okay, and that's what we are trying to compute, right? A simple answer is first compute the sum. So this sum will be a1 into n1, and second sum will be a2 into n2 divided by n1 plus n2. Sounds good to you? All right, so that is how you compute the average of values recursively using a combiner and a MapReduce phase. Good. Now, I'm moving ahead. If you have any questions, you can ask now. So the way you generally apply a combiner is by the way of job.set combiner class. Okay, and you generally mention your reducer itself. And the way you program, I'll show you my combiner in case of the frequency problem. The numbers was hugely different. There was a tremendous amount of performance improvement in the code of frequency computation due to combiner. Okay, let's have a look at, let's say go into my SG test, and there is a character count here. So this is my combiner. And combiner basically does nothing but do the summation exactly like your reducer. So effectively, there is not much of a difference between a reducer and a combiner. And in the driver, when you are doing this, you generally mention it here, like job, the way you mention partitioner, same way you mention your combiner, and there we have. Okay. Next step is data locality optimization. Yes, let's have a look at the combiner function again as per Anand. Now here what we are doing is look at only this piece of code. Okay, here we initiate our sum value, we iterate over all the values and then sum it up and then return the value. Return in the sense we are writing to the context. So Anand's question is reduce going to get all the values for this key? Is that your question? Here, will we have whatever array we have got here, these values, is it complete array or is it partial? Is that your question? No. So it's not complete because your combiner is going to be called multiple times. So if there are a million values, out of million values, combiner might get in one shot, combiner might get maybe two values, maybe three values, maybe 50 values. It's unpredictable fairly. All right. Yeah, we can say that all the values it will get, whether 2 or 3, will be the values belonging to the key called A. Okay. You should try to run it. So mapper will be running on a node. So your mapper code will be generating key value pairs. Hadoop will be combining it. If you remember correctly, Hadoop sorts on each node as well, not only in the reducer, but on each node as well. Therefore, Therefore, while sorting and figuring out the key values similarity, that time for a key, all the values, a subset of these values will be given to a combiner. Combiner will be called on a subset of the values again and again until the subset is all merged into a single value, until the whole set of values is merged into a single value. Anand, was I able to explain to you? No? Okay. Sergio is saying, so this is more like reducer optimization to improve network traffic with the use of combiner. Perfect. That is correct. Also, yeah, also delegating lot of work of reducer to mapper in order to the way instead of leaving everything as sorting to reducer, Hadoop tried to sort the mapper's data on the local machine itself. Similarly, it we are trying to offload the reducer to individual machines. Great. All right. This function is a combiner function or reducer function. So interesting thing is the definition is exactly same. A combiner is also defined like extends reducer. Okay. So it's exactly the function definition. Everything is same. Okay. There is no issues with that. There is no signature differences. It's only the way you are putting it in driver. Here you can see we are telling that, hey, this is my reducer and this is my combiner. All right, though the definition of mapper and partitioner are fairly different. Now there is something called data locality optimization. We had been talking about for quite some time that Hadoop tries to execute your mapper on the block, near to the block, near, and it tries its best to execute it very close to the block. So there could be multiple scenario. Imagine this is a data center. Imagine this is a data center, and in this data center there is the map task, there is a HDFS block. Okay, me in here, it is the map task and the block is on the same machine, while in the second case it so happened that they are on the different machine but on the same almirah or same rack. And in the third case, the mapper and the block are on different racks. Okay, there could be one more scenario where your data is on one rack in this data center and your mapper is being executed in another data center. So from left to right, a out of A, B, and C, A is most preferable to Hadoop. B is little lesser preferable. C is further lesser preferable to Hadoop. So it tries first to get it done in the manner A on the same machine. All right. Now, okay. So before we go forward, here are a few questions to you. Can reducer take the benefit of data locality optimization? So this is called data locality optimization. Hadoop's tendency to prefer A over B over C is called data locality optimization. Tendency to keep the data local as much as possible. Tendency to move the code instead of data, right? So can reducer take the benefit of data locality optimization? Anyone? What is your guess? Good. It cannot, because reducer anyway have to combine the data from various node, and therefore it's not possible for reducer to take the locality. I mean, at most it can do is it can execute reducer on one of the mapper nodes, but still the other data which is being executed on other mappers, it has to come to that particular node. Okay, if you have to store a file with a replication factor of 3, on which all nodes will Hadoop store this file? Anyone? Yes, 3 is okay, but on which all nodes? What, which 3 nodes will be there? Refer to this diagram. Which 3 nodes will, imagine you are on this particular node here, on this node, or let's imagine that you are sitting here. Okay, let's imagine that you are here. Okay, let's imagine you are in this block. Okay, you are logged in onto this machine. There is a file locally available. You are copying the file into HDFS here. So what will be the tendency of Hadoop? Where will those 3 copies of blocks go? Okay, okay. So Anand's take is that on 3 racks possible. Okay, good. But this is something which Hadoop keeps improving every time. So one is First copy will just move from local your folder into the folder where HDFS has saved data on your local machine. Okay. Second copy will be off the rack on another nodes. This way, because there are two things a Hadoop has to defend against. First, the first thing is if you keep all data into in a single locality and there is a fire in that data center, your all data will get lost. Therefore, it's advisable to keep at least one copy of your data far, far, far away. Okay. Second thing, in case it keeps data really, really far, there are high chances that connecting to that node and executing your work and bringing that data from the distance very far to the reducer running in one data center might consume a lot of network time, right? So these are the two things Hadoop tries to optimize, okay, by keeping one on the local node and other on to off the rack on a different rack on a different rack. Yeah. All right. So that's a general way. Now, the way you tell Hadoop that this is my network topology, you basically name each of your computer in the form of a directory structure. Okay. You start saying my first node is S1 slash R1 slash N1. Okay. That makes it like a tree. Okay, so basically each node you give the name in the form of slashes, A slash B slash D, and out of these slashes, it creates internally the tree structure and then computes the distance between two nodes. All right, so for example, if this is one node, you will give it what name? S1. If this is S1, this is R1, and this is node 1. So it will be S1 slash R1 slash N1, and so on. Okay. And the way this is called network topology. So basically, you write a program which will convert an IP address into this form. Whenever Hadoop asks your node, hey, what's your name? When the node comes up, the first thing Hadoop is going to ask this node, hey, what's your name? And it will reply, I'm S1 slash R1 slash N1. Okay. And the way Hadoop will call it, it say, hey, node 1, your IP address is this. What is your name? What is your network topology name? And this is what it'll say, I'm this. And based on the answer, Hadoop will form a graph like this and then start computing the distances between the nodes. Okay. Now, this whole feature is being done, this is called rack awareness. Understanding the network as a tree, and the way we have specified is each node is characterized as slash A slash B slash C, and we basically create a topology script file, and and we basically specify that file into Hadoop, and that script will basically get an argument as IP address and will print out the topological name like slash A slash B. Okay, and the distance between the node will be computed as the time taken by one node and another node. Okay, so the distance from node 1 to node 3 is how much? Who is your common ancestor of node 1 and node 3? This one. The distance from common ancestor is this and this, and you sum it up, so that becomes the distance of node 1 and node 3. Okay. So basically, the distances from the common ancestor of one node to another node, the summation of the distances will become the distance between the two nodes. Okay, sum of the distances from common ancestor. Common ancestor is for this node n1 and n4. Who is the common ancestor? Oh, okay. So distance computation is done like this. Is my voice clear better now? No. All right. So the way distance computation is done is from one node to another node, we find the common ancestor, and then after we have found the common ancestor, we basically compute the summation of the distances. So node 1 and node 3 has got common ancestors rack 1. The distance between node 1 and rack 1 is 1, node 3 and rack 1 is 1, and hence the distances are 2. Okay, 1 plus 1. Now you can notice the distance between node 1 and node 2 is same as the distance between node 1 and node 3. Alright. Similarly here, the node 1 and node 4, what is the distance between node 4 and node 1? Anyone? So who is the common ancestor? Switch 1. Distance from node 1 to switch 1 is 1 and 2. And node 4 to switch 1 is 1 plus 1, 2. And total is 4. 1, 2, 3, 4. It's like you start walking from node 1 via the common ancestor, the closest common ancestor, and reach node 4. Sounds good to you? Great. So that's mostly about, and the default behavior of rack awareness is based on IP address. In I mean, effectively, this is how it looks like. Each IP address is converted into a path like this, okay? Which means if only the last digit had changed, the distance will be very small. If the second last digit is changed, the distance will be really, really high. If only last digit is changed, the distance will be 2. If this digit is changed, the distance will be 4, and so on. If this digit changed, the distance will be 6. And this digit will change, distance will be 8. Alright? So you can see the same thing here. So it can be not only local IPs, it can be your public IPs of data center. Okay? If there are two data centers you are having, they are remotely located, then it might have public IP addresses. It all depends on how it is structured, how you have structured your. If it is under your own local area network and you have prepared your own routers with some IP schemes, then it will be completely up to you. All right. So the preferred is that the distance on the same computer, okay, the distance here in the first case is 0. This is 0. This is 1. This is 2. This is 4. This is 6. And so on. Alright? Is it clear to everyone? Alright. So that completes our rack awareness. So basically you can configure it by creating a script and specifying this property in the configuration file. And this script will take this as the argument. IP will be given it as argument, and it will be giving out something in this form. Okay. All right. So this is the end of the session number 4. Okay. Now let me open the session number 5. All right. So okay. So I'm moving on to something called pig now. All right. Any questions for me right now? All right. So, what exactly is pig? Pig is basically a client which converts your SQL-like language called Pig Latin into MapReduce for you. Okay, it provides you things like join, order by, filter by, and all of this in a very simplistic language. Pig Latin is very close to what SQL is. All right. So we'll talk about why pig, why not SQL Hive. We'll talk about that and discuss it. Okay. So pig basically is a client. Pig doesn't have a server. It's a client library, and it gives you a nice command prompt also, where you start writing your code, writing your queries, and it will run. Okay. So the way the language has been designed is to create the data flows. The data flows from loading the file, then understanding it, then filtering it, then just like your temporary tables, or just like your other form of data flow, Pig also provides you the data flow kind of a construct. All right. Now, for the impatient, this is how the pig would look like in the end. Load this data, and we are specifying a column in it, and we are giving it a name called input. Input basically will represent the data as given in this file, one line as a column. Okay. Then in the next one, what we did was we tokenized the word. We broken the line into words by using a function called tokenize, and then converted one word per row. Okay. Here each row contained a line. Okay. Now group the words by particular word that forms the group, and then you iterate over the groups and do the summation. Okay, that's all. And you get the count for each of the word. So this is these 1, 2, 3, 4, and 5. These 5 lines basically gave you the word count problem very quickly. Okay. So Piglatin is basically a data flow language that helps you describe how the data flows. If you notice this, this is how our data is flowing from the file into input, from input to words, from words to grouped. Okay. So on the left hand side is newly generated data set. On the right hand side of the equality is the data operation, and there are various kinds of data operations such as load, iterate over the records, group the data by something, and then you have these commands for dumping onto the screen or storing into the file. Okay. Yes. So we will talk about, first let's compare pig against MapReduce. Okay, we'll talk about it in a minute. It allows you describing how the data should flow, how it's read, how it's stored, and how it is processed. You can create very complex workflow, and still your program will be very readable. If you see this whole thing is fairly readable. If you try to do the same thing using a complex SQL query, the query will become un I mean, will so complex that it'll look really difficult to understand. Okay. So basically, the data is split into multiple streams and so on. Okay, it does not provide you things like while loop or normal for loop, or it also does not provide you if conditions. So it's not properly structured language. It's mostly like a query language. It's a data flow language. All right. Now the benefit against MapReduce are far far obvious. For example, MapReduce basically is very difficult to write. If you had noticed, it actually requires a far more planning and far more understanding of the programming language such as Java. Okay, that is MapReduce. While in Pig Latin, doing joins, group by, and these kind of basic operations is very very simple and straightforward. Okay, Pig Latin. I mean, Piglatin provides you a fair amount of optimizations in the language itself. Now, MapReduce code does not know anything about your data, while Piglatin lets you describe your data. And in case you try to call an incorrect function on a data, it tells you on the face that hey, you are trying to call this function on an array while this function should be called only on this kind of object, right? That kind of control is not there in MapReduce. Okay, MapReduce code is far bigger to write. There is so much of effort that goes into it. First you write the code that is close to 170 lines, and once you have finished writing the code, what you do is create jar, upload it onto the server, and then do the job. All right. Now, Pig Latin might have minor limitations. Pig Latin has minor limitations. Okay. So now Johnny's question is when we decide which one to use, in very simple words, if something you are trying to do, if it can be done in Pig Latin, do it. Don't go for MapReduce. In case you are really writing something for which there is no construct in Pig Latin, then you try to still create something called user-defined functions in Pig Latin. And in case user-defined function is not possible, then you think about how to write the MapReduce for this problem. Okay, so if you can avoid MapReduce, it's great. Reason being, the MapReduce code, the Java code will be less maintainable as compared to Pig Latin code, because Pig Latin code will be far more readable, far more easier to understand. All right. Now, you might argue that why Pig Latin? Why not SQL? Why Pig Latin? Why couldn't we use SQL itself? Why do we need a new language? So people started with SQL only. Like Hive is an example that they started with SQL, and Hive basically convert your SQL into MapReduce. Okay, but there were limitations of SQL. SQL was designed basically for small data. It was not designed for this kind of usage. Okay, so when you are churning big data, you have to optimize at various levels. You have to optimize your queries. You have to exploit the various kinds of properties of data. So same query cannot work for all kind of data. While when we were writing SQL, we basically did not care whether our data has 10 rows or 100 rows or 10,000 rows. right? So SQL was not really designed for something like a distributed computing. Therefore, the creating the construct like, okay, I want 10 reducers, those kind of configuration thing that gives you more control, okay, were not possible using SQL. Okay, therefore the pigletin was designed. Second problem was in SQL we could only work with well structured data. So we first define our data that this field, my input file has got these many fields, these many columns, this is data type. Only then we were able to use SQL. Once we have converted our unstructured data into well structured data, only then we can actually utilize SQL. While in case of pigletin, you can load the raw data and then the pigletin itself will help you do the ETL on your big data. Okay, those are the first most important reasons why to use pigletin. Okay, performance plus plus unstructured data. Now, so those are the main two reasons. Rest is just a theory, you can go through it. Okay, so there are many use cases of pig. One was research on the data, of course, then iteratively processing, doing the batch processing of various kinds of data, doing ETL, and there are many things wherever analytics is possible, you might like to use things like pig. The basic philosophy of pig is it eats anything. Okay, whether your data is structured or unstructured, it's okay with it. All right. Pigs live anywhere. So the other philosophy, the pillar is that it should be able to do the computing not only for Hadoop but also for other distributed frameworks. Third is pigs are domestic animals, meaning pigs are very well controllable. In case it provides you various kinds of custom function ways for streaming. Also, you can have custom load and store methods. Okay. D is pigs fly, meaning pig has been designed for performance reasons. One of the pillars of the philosophy is pig should be really fast. Okay. To install pig, because it's a plain vanilla client, you can start just download the jar. Even if you don't have a Hadoop, you can download it and run it. Okay, unzip it, and mention the Java home variable, and then don't mention this one because this is for my machine. You find out your Java home, where have you installed Java, and then you can mention that as Java home. Once that is done, you can start running pig minus local. Okay, pig minus x local. It does not require Hadoop installation. If this runs, that means everything is in place. Next step is defining a variable called class path, where we will tell that where is our Hadoop installed, where are the configuration file for Hadoop, and based on that, pig will figure out how to execute your MapReduce, who is name node, who is task tracker, and so on. Okay. Now, once you have defined the class path, then you don't need to run it in local mode. You can simply run by pig. All right. Although you do not need to install any of this because we have installed pig clients on all four machines: Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4. So all four machines contain your installations. Okay. All four machines you can just SSH and just type pig and start running it. So, like for example, I'm already logged in here. Let me log in again. Is the font visible to you? Can you see the font? Is it clear enough? So I'm logging in into Hadoop 1. In case Hadoop 1 is busy, use Hadoop 2. Okay. In case the Hadoop 1 says that cannot allocate the memory, just use the Hadoop 2 because multiple people might be using it. All right. Now, this is the grunt. This is the command prompt where by default all the fs command, Hadoop fs commands run just perfectly fine. You see this? I did ls and it gave me the listing of our home folder. Our home folder is user student. It gave us the listing of that one. I can do as Giri and then still say okay. So this is an additional advantage of using this console given by Pig. Okay. It also provides you very help functions. You can go through it and you'll find that lots of functions are available. Okay. You can say copy from local. Okay. You can see that copy from local. Okay. So this way you can copy the data from local machine. Okay. Other than that, you can start writing the commands here and it'll be done. Okay. So now I have actually, let me do pwd. I go back. I've put the data in this folder. You can see in this folder all the ratings and everything. All right. Now, okay. So the other thing is, in case you are just testing things, you can run things like pig minus x local. Okay. Do you remember our MR unit program? Uh, when we were doing testing, it was running your MapReduce locally. So basically, that is a Hadoop emulation on local machine. So pig minus x local is local. Now it does not. If whatever we do, it would not bother Hadoop installations. Okay. Now, so you can do multiple things. One, you can run pig, and if you have hundreds of command already, you have coded them. You can simply create a file, put all the commands in that, and then you can run pig and pig script. Second is, if you just want to execute only single command, you can do things like pig minus e and ls. Alright? So it gave me the results and other options are available. Alright? Other than all these fs commands, what you can do is you can kill a job if there's a jobs running. Okay. Alright. So let's take a break of 10 minutes and come back at 10, 10, 1, 4. Yeah, it actually looks like a generic Linux command, and tab actually works, and also up down keys work. Okay. All right, so should we start now? Or let me wait for few more seconds, okay? So should we start now? Yes? Is everyone back? Should we start? All right, so lot of analytics actually is done on using pig, all right, other than SQL. Now, the basic construction of pig is simple. Each processing step results in a new set, and it is case insensitive. Okay. The user defined function are case sensitive, meaning when you define a function, then it is a case sensitive. Other than, like, load can be written as capital or small, it's the same thing. Or filter, join, all of these keywords are case insensitive. Like with any query language, it provides multi-line commands and single line comment. And so a very simple script would be, given this kind of a file which is tab separated, what we want as a result is, for each of the ticker or for each of the symbol, we want the average value. Okay, so how would you do in your SQL? You will say group by this and then do the average, right? Oh, all right. So here, I mean, Johnny, can you hear me clearly? Because we had already started 2 minutes back. Okay. Now here, our objective is to convert this kind of data into this. We want to compute the average value of this for each of the ticker or for each of the symbol. Okay. Basically, what we are trying to do is group by. So this is how the code looks like. You load the data, you examine the data, then group by, and after group by, you have for each, and then you save the result into this folder, this file, and then you can see the file using your normal HDFS commands. Right? So this is how your default uh, query looks like. Sounds good. Now, again, so we'll generally go back and forth when we are studying a language. We generally go back and forth the way we showed you a hello world script earlier. Then we talked a little bit about pig script. Then we have again showed you, we are showing you again a average value function, and then we are going back into the details. All right. Now, so most importantly is data types. Data types, there are the basic ones, the scalar ones. The data types are mostly like Java because Pig is designed into Java. So all the data types are similar to Java, starting with int, long, float, double. Char array is string array, and byte array is byte array in Java. Okay. Now, the most interesting part is the complex data type. Complex data type are of three kinds. First is map. When you want to store a key value pairs, lot of key value pairs are there, you want to store your data in that form, then you use map. Okay. So, and when you're loading the data, it expects the data to be in this format. When you are loading the map, it expects the data to be in this format. All right. So the map is basically a key value pair. Key can be a character array only, while value can be either the scalar type, the basics of any type, or it can be a complex type. Now, on the similar line, there is something called tuple. Tuple is equivalent to the row in the database. Tuple is essentially a fixed length ordered collection of values. You can think of tuple like an array, okay? Like an array which can be either on index based, or we can also give the name to each index. That is the tuple, okay? The way we have always looked at the columns of a table is like a fixed length ordered collection. Okay. And the way it is stored is using the round brackets like this, and it expects in there. Now, what is bag? Bag is nothing but a collection of tuples. You can think of bag as if the bag is a bunch of rows. It's like a table. Okay, bag is most likely a closest picture is bag is like a table. Okay, containing where table contains rows, bag contains tuples. Okay, the other property which separates bag from other things is bag. If bag doesn't fit into the memory, bag is stored onto the disk. Okay, so that is one thing. So these are the types, basic data types of, one is complex type, other is basic data types, and these will be useful as we go forward. All right. Any questions still here? Now, what do I want to do is, just a second. All right, let's start with here. All right. Now, let me show you what do I mean by these things. So let's go ahead and have a look at ls. So there, let's go into cd data and then ls. Here you will see something called a baseball. Okay. Just a second. I'm trying to locate a nice example. Yeah. So let's look at this. All right. Here we are loading this baseball file. What does baseball file contain? Okay, it contains, all right. So there is this baseball file in our database, which basically contains the details about every player in baseball teams. For example, for example, let's take Ben. So Ben Jobrist is one player who plays for Tampa Bay Rays. That is the team name. These are the of character traits of this player. What are these character traits? These character traits are nothing but bag of tuples. Each tuple only has single column, and there are multiple such tuples. Then there is a various kinds of hits, the various kinds of other details. What has been the history of this player? That is a hash map. Basically, it's a map. Okay, it basically contains any number of key values. It says games played is 297, hit by pitches is 5, on base percentage is this much, grand slams is this much, and so on. All right. Sounds good to you? So this is a map. This is a bag, and this is a string, which is character array, char array, and this is string. All right. So when you are loading such kind of data, you can load it like this. You can say load baseball, name is character array, team is character array, traits is a bag, and the batting is, history is a map. All right. Now, similarly, so if you have to load your dividends, for example, this one, okay, let's just load it. We are saying here dividends equals load this file. This file you can see in the folder here. You see the file here. Load that file, and under that, what else we did? We said exchange is a character array. Let's show you what does this file contain. You'll get a better idea. This is an HDFS file. It contains the stock exchange name, then the ticker, then the date, and then it contains the value of each one. Okay, so basically we have just loaded this data as these four columns. Okay, all are scalar types. Now if you do dump dividends, dump essentially prints out on the screen. Okay, so it has started the process of running it, and it'll take some time. All right. So what what exactly are we trying to describe is that Pig does not care too much about schemas. Here, we were very upfront that we said this file contains these four columns. First one is a string, second one is a string, third one is a string, and fourth one is a float. Now, next is you may not choose to define the data types for various fields, and Pig will be completely okay with it. So this is also a fairly valid point. Okay. Next is you can also omit all the column names. you can say simply like this. That's also okay with pig. Okay. Whenever needed, it will try to cast each parameter and then solve your problem. If you don't provide the column names, it gives them the it gives them like an array index starting from 1. All right. It will try to guess the data based on the data type. Based on the what kind of data it is, it will try to guess the data type. Next is you can, for complex data type like we had, either we can say that A is a map, and let it figure out between what and what. Or we can say, we can say, we can actually, this is same things. We can simply say A, or simply we can say A is a map, or we can say A is a map where tuple is contains two columns. So A is a map of tuples containing two columns. First column is integer, second column is a byte array. Okay. Similarly, you can say a tuple. A is a tuple. While we define the column, the way we have defined here, we said dividend is a float and so on. Okay. Similarly, we can say either empty bag, or here we can also say it's a bag of these tuples. Sounds good? All right. Just like Java, you can cast one data type into another. All right. Now, so that was a little bit of theory part. Let's get into the action now. Okay. So we can load the data of NYSE just by saying divs equals to load this. Or we can say divs equals to load NYSE dividends using pig storage. If your data is separated by comma. Okay. By default, by default, pig uses tab as a separator. In case your data is comma separated, you can use this kind of a syntax. Okay. And when you are specifying the name of the file, it by default assumes that you are trying to read the data from HDFS. In case you want to specify something else, you can specify that. In case you want to specify absolute, you can specify absolute location on HDFS. Sounds good to you? Now, next is in case there are multiple files and you want to load all of them into a single data set, you can put asterisk mark and it will load all those files into this particular data set. All right. So load, and the third is in case your data is not in HDFS and you want to load it, then you can use HBase storage. Okay. Th- Third, next is that you can load your NYSE dividend with the detailed data type descriptions of each column. Okay. Now, any questions on this? Any questions? All right. Now, my next point here is you may not have question, but I was expecting few questions like what if my data is in JSON, or what if my data is in XML? Okay, so the way pig storage is there, similarly there is something called JSON storage. Okay, using JSON reader, I think it's JSON storage or JSON reader. Using that, it's inbuilt into Pig. Using that, you can load the data from Pig into using this JSON reader. Okay, you can load the data from HDFS, which is in the form of JSON, into Pig. Okay, so who is not aware about JSON? Is everybody clear about JSON? JSON, good. So you can utilize those kind of values. Okay. So Santana's question is that for that also it's the same load command. Actually, there is a JSON loader which you can utilize. So you can utilize a JSON, or it is, I think it is JSON storage. I think it's all capital. What does it say? Now it makes sense, yeah? So it says could not resolve JSON storage using imports. I think it's called JSON storage only. I had just looked it up. Yeah, JSON loader only. That's correct. Thank you, Anand. So yeah, that's right. Let me just, instead of saying this, we can just say something like this. All right. So yeah, so basically you can utilize a command like this. So you can say things like this, but the only downside is you have to specify your data types upfront. Okay. All right. Now, next is that once you are loading this, okay. Next is that you would like to debug things in between. Okay. Yeah. So here we try to load things like this. Okay. Now dividends, if you want to know what's inside dividends, we can say explain. So it shows us all the data types. You can see it shows exactly what it is. So at any point of time, you can basically utilize explain. Also, you can utilize describe. Describe basically simply gives you only the data types. Okay. Describe shows you the data type of the field you're talking about. while explain gives you the full query plan. All right. Now there are many syntax highlighting tools. Eclipse is there, Emacs is there, TextMate is there. They're all having one syntax highlighter for pig. Now that was load. Load loaded the data from HDFS or some other location it can handle using HBase storage, for example. To save the data back into HDFS, you can use store, or to save the data into HBase, you can use store. When you it is opposite to the load. All right. So this basically stores the data to a file or other storage. Okay. Basically, once you are done with doing the processing, you save it back into HDFS or HBase or maybe some other location. Okay. If you just want to see things quickly, you can use a command called dump. It will show you the variable value on the terminal. Okay. This is very useful for printing and debugging your scripts. For example, we can say here dividend is there. We can say dump. Okay. And it is trying to read the data and then we'll dump it on the screen. Perfect. All right, so the after you are done with loading the data and dumping it, the next step is to do the iteration. You go record by record. If you want to churn the data, you can do that. Okay, it's like for each is more like going through each record and selecting that these columns I want to be displayed in the output. So this is more like saying select ticker comma value from divs. This is equivalent to that. Okay, so we are going through record by record in the divs and we are just picking up these two columns, ticker and the value. Okay, so you can see we have already dividends. And then we can say values, and here we can say dividends. So it says that it's not, but one particular column is not there. Let's see. We say describe dividends. And describe dividend, you can see that instead of the ticker, the one which we are talking about is symbol. Okay. So basically, under the values, if we say dump values, it'll give us what is this? So this is when we said describe, it did describe us. And why can't I see where did it describe? We say describe dividends, and these are the fields. Now here it's dividend. So what am I doing is out of all these four columns, I'm just picking up those few ones. Okay, I'm just picking up the symbol and the dividend value. Sounds good to you? And then I'm saying dump values, so it'll print us everything on the screen. Any questions on this? Am I going very fast? Okay, so you can see that it has printed these only these two columns rather than four columns. Okay, so in the way you have select query, select a comma b from my divs, for each behaves that way. Next is, in case you want to inside the for each, you can also do things like a normal mathematical operation between two values, like close minus open, or in case you want to refer these columns by their position, you can use things like $6 minus $3, 0, 1, 2, 3, 4, 5, 6, $6 minus $3, starting with 0. That's how we are referring. So this one and this one is same. It basically subtracts one value from another. Okay, it's like saying, it is like saying select a minus b from my table. All right, now the ranges are like this. Okay, for each prices generates all the columns up to open, which means it will give us these columns: exchange, symbol, date, and open, these four columns. So you can see this. Let's just load this one, and in case we just want to generate these columns, okay, we call them beginning, and if you see describe beginning, okay, okay, so here in the beginning, it's how many: exchange, symbol, date, and open, all the values up to open. Okay, now if we had starting with date, and now if you say describe, now it will have only these two columns. Sounds good to you? From date till open, from date till open. All right, so this way you can select the ranges using generate. So my question to you is, so this sounds good to you? We are basically iterating over the records and doing some sort of operations on them. So So do you think there is a need of a reducer code for this kind of a query? So whenever you're looking at big commands, you should, in the back of your head, you should have this thought that how will it be doing as MapReduce? Okay. So given this kind of a command, does it require any reducer side code? Johnny says no. Anybody else? Perfect. Perfect. There is no requirement of sorting. On the map side itself, if I had to do the same thing, I'll start subtracting the values and print in the output and tell that there is no need of reducer, so don't run any reducer or sorting. Okay. This way I'll get the results really, really fast. Now next question is not break. Okay. So next question is that for this, okay, there is no question. All right. Now there are further more details about for each. When you want to project the complex data type, is little different. For example, let's load our baseball one. Okay, like this. Now all we want is we just want to find out the batting average of every member. Okay, we just want to find out the batting average of the member. All right, sorry for that. So if you have to do that, what we can do is we can say name, and you remember there was a hash map bat. Under that there is a key called batting average. Okay, now you can see we can take this and select dump avg. It will only print that particular value of this key. If it is not found in that map, it will be blank. Okay, any questions here? Now next is out of a tuple. Imagine you have a bag. A field is a bag. All you want is only two columns out of it. In those cases, or there is a tuple, one particular field is a tuple, which means each field, this particular field is having multiple values inside it. Okay. In those cases, what you can do is you can you can basically say things like T dot x and T dot dollar. Basically, you can select the columns inside the tuple as well. In case you want to do the projection on a bag, not on the map, on the bag, then you can do things like this. Sounds good? All right. So you can basically here all I'm trying to demonstrate to you is you can do the column selection inside a bag and inside a tuple. All right. Also, inside the for each loop, you can do things like a complex computation, something of this sort. Okay. You can do these kind of computations. Sounds good. And you can apply all kinds of functions on each of these values. Say you want to say square root here, or you want to say other mathematical operations, you can apply all of those. So for example, we can say like here, we can say sqrt of these values. Okay, we can say like this. And there are so many functions which you can utilize. These are mathematical functions, these are regular expressions. You can utilize all of them in the for each. Okay. Is everybody comfortable with for each? No? Great, great. So I will move on now. The after after for each, the next construct of utmost importance is group by. All right. Now you will notice that unlike our SQL query where select A comma B from a table. Okay. So I'll show you this. We say in a SQL query, select A comma B comma whatever we want to say here from table. Okay. Now this is separated into load. This becomes our load. Select this becomes our for each. Okay. And in case there is a group syntax, let's say select A comma average values from my table group by A. Okay. This is our SQL query. So how many of you are comfortable with SQL? I think everybody is comfortable. All right. Now this one will be broken down into load load my table first. Okay. Let's say M, and next becomes uh, projection. Projection is, or you can think of it as like group equals group by, and then next step is for each. So a single query is broken into three separate steps, and that's what uncomplicates the whole game of pig. Okay. By the way of breaking down the full SQL into multiple steps, it uncomplicates the life. Queries are far easier to understand. So let's say there is a table A on which you want to create group. You can say group A by F1, group A by F1, comma F2. All right. Now the input, if your input is this, it will become this. So if your input is John 18 4.0f and Mary 19 3.8f and so on. Okay. So when you say group by A by age, then Joe, this record and this record, they will come together like this. They will form a big bag. They will form a big bag of tuples. Okay, these were separate tuples: first tuple, second tuple, third tuple, fourth tuple. When we said group by, these two tuples combined together and formed a bag. All right. So group by is basically grouping it into two things. First, if group by results in this kind of tuple. This tuple contains first value on the basis of which you uh, created the group. If you created the group based on two columns, here will be a tuple instead of a scalar value, and it will be like a comma b inside the brackets instead of 18. And the second one is a bag. Okay, the name given to these columns is, this one is given name. So when you describe this b, you will get things like uh, it, it is given a default name as group, and this full bag is given the name of the actual data set. Okay, the actual data set on which you created the group. All right. Now let's have a look at what will you do with the NYSE dividends. So okay, before we move to filter, next one is filter. So everybody is clear about group by. What is this group by doing? Are you comfortable with this whole syntax? So if A was this, group A by something would look like this. Okay, so B will be a group, and then it'll be the value, the second column name will be A, and the values will be exactly like what we had earlier. All right, great. Now, the next step is filter. Okay, so the where clause of standard SQL query is converted into filter here. So we load the data into divs. The next step is we filter divs by particular condition. After by, we write conditions. Okay, so a condition can be a normal one where A matches B, or A is greater than 10, or B is greater than 12. Or you can create complex conditions by putting AND, OR, and other logical operators. Okay, so let me show you this. Let's load this data. So we loaded divs, then we say starts with this, and then we say dump this. Anyone? What will this command do? What does it mean? Can anybody guess? What does this command do? Okay, it does like, but what kind of things will match with cm dot star? What kind of symbols will match with cm dot star? Yep, symbol will match. But my question is that what will be the values of symbol which are I am trying to figure out if you understand the meaning of regular expression like cm dot star. What does it mean by cm dot star? Starting with cm, perfect. Starting with cm, and then at least one character afterwards. No, at least zero character after this, not one, zero characters. All right. So basically, anything that starts with cm is okay. Even the cm itself is okay. Now you can see this. So in the result, we got CMU, CMK, CMI, CMS, CMO, CMA, and CMC. Perfect? Yep, you're right, Anand. All right. In case you want to negate it, you can say not here. And in case you want to put a conditional, the AND operators, the logical AND, you can put it like this. The other command you should have a look at here. Other full exhaustive commands. All right. So this way it converts it into filter. Filter basically filters the data. Now next is, all right, my question is, will there be any reducer generated for this? Anyone? We said after loading the data, we said filter this by where symbol is matching with the regular expression. Do you require a reducer for this? Anyone? Why would it need sorting? If we had written something like the regular expression like this, will sorting help us in any way? Okay, good, good. So yes. So the answer is no, because it wouldn't require any kind of sorting. We can do it on the map side. So in our map itself, while generating the key or values for the consumption of reducer, we can actually filter the data then and there. All right. So filter is clear to everyone. Next is order by. Okay. So order my data set by either one value or a composite values, and we can also say descending or ascending from here. If you want to order the data by a particular column in descending manner, you can say things like this. Okay. It basically orders the data. Second is distinct. What does distinct do is very obvious. It basically finds the distinct values for distinct values of tuples. All right, so let me show you. Just running it. So it will basically give us distinct symbols. All right. Now, question to you is, will it generate any reducer code? Anyone? So Anand says yes. Anybody for yes? Yes, that is correct, Anand. So whenever you do distinct, it has to first sort and then do anything else. In those cases, it would require sorting. Therefore, you will require reducer. Perfect. All right. So up to here, everything was simple, and you would be wondering that you could do it better if you used your MapReduce, right? But when it comes to joins, then the problem statement becomes a little more complex, because joining, if you remember in our session where we were having this strange democracy and we were computing the votes, there we were just trying to join two tables and it was too much of headache, right? So Pig has simplified that life. It has absorbed most of the complexity in it and has given us a nice uh, keywords to compute the joins. So you can say things like load data, and then you load it two data sets. You can say join A by a particular key and with another data set on some other key. This way, all the values which are matching from daily of this particular column will be will be matched against divs in this column, and you will get the results. All right. Now, in some cases, you might want to compare a full tuple. You might want to compare multiple values, or you might want to compare composite keys. These are composite keys, and in there you can simply write join A by A1 comma A2 and with B by B1 comma B2 and so on. So it is possible to do the matching on that basis. All right. Now, when you join two tables, you cannot just do a self join like a standard SQL. If you are doing a self join, you will have to load the data twice. Like here, we are loading the same data into two divs for creating for joining the same table with itself. All right. So self join is little tricky. You have to basically load the full file again. All right. Now, there's a little bit difference between standard RDBMS join and this join. This join should have at least one column. Okay. Unlike our SQL joins, there when we were joining two tables, even if we did not provide any where clause, it will join it. It will do a cross product. Okay. But in case of pig, you cannot do uh, you cannot do a join without a condition. There cannot be a join without without a criteria. You have to match some column. Okay. Second is, you cannot join based on inequalities. Something like a dot value greater than b dot value. This is not something supported. The join is only supported on fixed columns. Okay. Join is only supported as equality, where one column from one table is equal to another column on another table. Okay. Can somebody guess why is it so? Why are these two restrictions? Why is it that we have to have a column for joining? Anybody? This is a random guess. Give it a random guess. When we are joining two tables, what exactly is going inside? Inside it's basically creating MapReduce, right? So why do we need to always specify at least one column for joining? Perfect. Thank you, Anand. So it needs key for the mapper. So how it will be joining the two tables is by creating a key on the basis on which we are trying to join the two tables. It will create the key on the same columns on which we are trying to join, right? And that way it will bring the two records from both the sides together, right? So, and mapper requires a key. If you don't provide mapper a key, it will not make any sense. And the same is true in case of the second one, because if you think about normal SQL, it is fairly okay to say select star from a comma b where a dot value is greater than b dot value. But that is not legal in case of our joins. All right. Now there are something called, this is normal join. Again, I have presented it pictorially. If there are two data sets A and B, A has got ID and B also has got ID. A's IDs are 1 and 2, B's IDs are 1 and 3. If we do a simple join, we get 1 comma Sandeep, which is this one, and 1 comma Giri, and which is that one, right? Now, what if we need the left hand side values invariably in the output? Now you can see we need the 2 comma Ryan, right? In those cases, we do an left outer join, or simply left join is what we use. Okay, we use left join. I mean simply left or left outer. Okay, so what does it mean by left outer? You put a comma between join A by ID, comma B by ID, right? So before comma, you put this syntax saying left outer. In left means the left hand side of this keyword is A, which means no matter what, we want the records from left hand side in the output. All right. Sounds good. This is called left outer join or left join. Now, if you want the right hand side, which is B, in case even if there is no matching ID from left hand side, still you want all the things from the right hand side. So say 3 is not matching with anything, and still you want 3 in the output. Then you say right join or right outer join. Okay, and then there is something called full join. Full join means there is a normal join, okay, where id from left hand side is found on the right hand side, and for those which are not matching the other side you place the null here, like 2 Ryan and then null and null, then 3 Saha has null and null as the first two values. Okay, sounds good to you? Are you with me? All right, great, great. So everybody is awake and everybody is listening to me. All right, so this sounds good. Now our question to you is, if we did join A by ID and B by ID and we got N1 records, and when we did join A by ID left join with B, we got N2, and we said, and second is the right join has got N3 records, left join gave us N2 records, and the normal inner join gave us N1 record. What will be the number of records in full join? Okay, can somebody tell me? Okay, let me. Perfect, perfect. Thank you, Jim. Anybody else? Any questions on this? All right, any questions here? No questions. Okay, okay. All right. So another question for you. What will be the result of this? We have A on the left hand side. It has got two rows, 1 and 2. B on the right hand side. It has got two rows, 1 and 3. Now, if you do join A by ID, B by ID and do a left outer, what will happen? What will be the outcome? 1 comma 1 comma 3. Okay, but actually it's a sort of a teaser. Okay, it basically gives an error. Okay, because this left or right, whatever you join it, should be before this comma as per the syntax. Next is, what will be the result of this one? Join A by ID and then outer comma B by ID. Anyone? What will be the outcome? Yes, that is correct, Johnny. So, so the result will be error. Good, 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 Sergio. And now So sometimes we just want the first 10 records. In those cases, limit will do a very brilliant job. Now, there is this new syntax called sample. Okay. So when we deal with big data, a number of times data scientists want only the samples. Okay. There is a difference between sample and a small record. Sample is randomly picked from from the whole set. Okay. It's fairly random. All right. So when you say limit divs 10, it means only give us 10 record, first 10 record. When we say sample divs point 1, it gives us top 10% records. Not top 10% record, random 10% records. Any questions? All right. So one question for all of you. Okay. So Anand's question is, how do we get last 10 records? Interestingly, a pig doesn't give you that kind of syntax. I also looked at for the same thing. I also tried doing the same thing but could not do that. Any other questions? Okay. So Johnny, I could not figure that out by myself. Okay. If there is a auto number, can we try something like or something? No, I did not get your question. If there is a auto number, can we try something like greater or something? Okay. To find last few words. Hmm. I think we can find that, yeah. All right. So I'll have to look into it, how to exactly find last 10 records. All right. Now here is one question for you. Okay. Say there is divs, we loaded this file, we computed this sample and then printed it twice. Okay. So when we run it twice, will it give the same output? When we dump it twice, does it give the same output or does it give us different? Will this dump will be different from the other dump? Okay, Sarju says it will be different each time. Okay. Second one may be empty. Okay. Jim says same. Okay. Interesting. Santana says it will be different because it is simple. Why? I did not get this. Okay, because it's a sample. You're right. So there is one thing which you should have noted by now. When we do any of this, okay, nothing executes. It's only when you say dump or when you say store, then it starts running the various commands. Okay, when you say dump, only then it runs the command, which means every time you dump, every time the sample will happen and every time load will happen. Make sense? So every time you basically run a command, all the things that it is dependent on, they all will be executed. Yes, because it's not storing any intermediary results. Okay, these are just notations saying divs means load that file, sum means find samples out of divs. That's all. It's not storing any data anywhere. That's correct. Calling some function with dump each time. Right. Okay. So the sampling gives randomized output. Okay. Therefore, the answer will be different every time. All right. Any questions before we move forward? Or you are done for the day? Okay, so pretty much means still there is a scope. All right. So the way we defined reducers when we created map reduce jobs, we always control the reducers. We never control the mappers. Same way, pig pig lets us define number of reducers by the way of this keyword called parallel. Okay, because as we talked earlier, pigs fly, meaning pig has been designed with performance in the mind. Okay, pig has been designed with performance in the mind, and probably all the database tools for big data are designed for performance in the mind. All right, so when we say things like this, we are saying group my data set by this symbol, by this particular column called symbol, and let there be 10 reducers. Okay, this parallel 10 means let there be 10 reducers. In case there is no reducer, this parallel syntax would not make any difference. Also, in case this parallel you are specifying the reduce again and again you are specifying reduce, then number of reducers, if you are trying to specify again and again, you are basically in every syntax, every group by, order by, everywhere you are saying parallel 10, parallel 10, parallel 10. In those cases, you can set in the environment variable and then needs to keep on using that. Okay, it will keep on using that environment variable. All right. Also, if you do not specify number of reducers, there is a default behavior of Hadoop, of Pig basically, and Pig basically creates the number of reducers, the default number of reducers using this logic. Okay, the logic is if you have got n GB data, there will be n number of reducers. Okay, divide the total data into 1 GB size, and then those many will be the reducers. Okay, so the default behavior is the default behavior of pig, not Hadoop, it's the pig. So the default behavior of pig is whatever is the data, how many, I mean, find out how many GB is the data. If it is n number of n GB data, then it will create n reducers. In case n is greater than 999, it won't create any reducer beyond 999. All right? Yes, up to only 999 reducers. If you have 2 terabyte data, still the reducers will be only 9 and 9. Okay. Any answers? How many reducers it will produce? For each divs generate symbol, comma, dividends. It's very simple. We have already talked about these things. There will be no reducer at all. Okay. There'll be no reducer. It's all map side code. Does parallel have any impact on this? Will you observe any optimization or worsening of the situation because of this? Because of specifying number of reducers. Will parallel clause have any impact in this statement? Yes or no? So it's the same clause as in the previous screen. For each generate symbol and do something. So yes or no? That's correct. Parallel will only have impact when there are reducers. Okay. All right. Let's take a break here. We will continue from flatten tomorrow onwards. All right. See you tomorrow. Have a great day ahead. Which one you're talking about, Santana? So I just told that we will see you tomorrow. Okay. So here all I'm trying to say is I'm talking to Santana that since there are no reducers, the parallel syntax will have no impact on it because parallel essentially computes number of reducers, and when there are no need of reducers, so effectively the parallel keyword will not make any sense. All right. Bye bye. Have a great day ahead.